Good morning, class. Today we're going to have a quick discussion about section 2.4. 2.4 in your book, rates of change, tangent lines, and sensitivity. And we're going to cover these 5 topics: average rate of change, slope at a point, tangent lines, normal lines, and then lastly, sensitivity. We'll do those in a quick, nice, and easy fashion, and I'll roll through them really quickly one by one and check them off as we do so. Okay, so first off, number 1, we're going to do average rate of change. For a function, when we talk about the average rate of change, what we're going to talk about is the change in f, or the function, divided by the change in the variable, or we'll say in the x. Okay? So the change in the function over the change in x. So this kind of translates to f of the first point, f of the last point, or like when we do slope, so we'll do f of 2 minus f of 0, and this would be 2 minus 0. So this gives me my change in the function values over that time limit. So that's average rate of change. It doesn't tell me how it's moved during that time. Okay? This is average rate of change. Check off number 1. Done. Now we're going to go with slope and the tangent lines. Okay, so now say we have a graph here. We'll call this graph, this is f of x. So this graph of f of x, we're going to look at this point here. Who really cares what this point is particularly, but we'll call it the point just above 0. Okay, so now we're going to look at the average rate of change. Well, let's look here. If I go with this line and I draw a line like that, okay, that's a long distance. Well, let's see if we can start shrinking this distance. If I start shrinking this distance, I get really, really close to here. Okay, I'm taking this and I'm actually going to I'm doing my change, average rate of change, and as I get closer to that point, my average rate of change goes down to 0. So this forms the limit, and then that gets us to the point where we can look at this as the slope. Okay, so a slope of the line at that particular point, we'll call this point A. This would be B, C, D, and then obviously I'm moving down to there, so we're going to get that. So what that happens to be here is we're going to do the change in y over the change in x. Okay, now, if I can take my change in y, f of x, and, okay, well, like this, f of x plus h, okay, my little piece of change, minus f of x, because that's my change, over here, I'm just going to have h. Okay, so that's kind of basically what we're looking at. Now, what we're trying to do is we're trying to take that change, start off at, we go from 3 down to 2, and then this is a 1. We want to take that all the way into where it's 0. So then we can write this as a limit. Limit as h approaches 0, or my change becomes super small, f of x plus h minus f of x. Oh my god. Oh no, I'm still rolling. Okay, I was about to type the question. Okay, over h. Now, what that means is now that this h will go to 0 for my function, and then we're going to look at an example. Again, this gives me my slope, and then what that will do is then in turn I'll be able to quickly get a tangent line. And again, I said we'll look at an example, so we're about to look at an example. Okay, what we're going to do now is we're going to look at this formula. F of x equals x plus 2 squared minus 1. And I'm writing it like this in vertex form just because vertex form is easier to work with for this purpose. Although it can work in either form. Okay, so we're going to look for this slope of the tangent line at the point 1, 8. If I plug in a 1, this is going to be 3. 3 squared is 9. 9 minus 1 is 8. So that point 1, 8 is on the curve. Just to remind you of that. So now we're going to look divided by h. Okay, we're going to do this, and what we're going to do is we're going to plug in these values. So where I see the x, I'm going to write x plus h. So this is going to be x plus h plus 2 squared minus 1 minus x plus h. I'm sorry, x plus 2 squared minus 1 all divided by h. And this is still the limit as h approaches 0. Now, if you spend the time to factor this out and simplify this all out, what you're going to get is the limit as h approaches 0 of x squared plus 2x h plus h squared plus 4x plus 4h plus 3 minus, and I put it in parentheses, x squared plus 4x plus 3 all divided by h. And our goal here is going to be to cancel out the h's. So what happens is I end up with the limit as h approaches 0 of the x squared cancels, the 4x cancels, the 3 cancels, and I'm left with 2xh plus h squared plus 4h divided by h. I don't know why I'm writing equals here. My bad. They're not equal. That is the limit of that. Okay, and this equals the next thing equals here, and this will equal. I cancel out the h everywhere, and I end up with the limit as h approaches 0 of 2x plus h plus 4 over, and then when I evaluate this at 0, I end up with 2x plus h. Okay, I'm sorry, 2x plus 4. Okay, 2x plus 4. Okay, so now my value is 2x plus 4, and I have a value at the tangent line of x equaling 1. So that means my value is x is 1. This is going to be 6. So my slope at that point is 6. So we're going to start here with a slope. I have a slope now of 6. So since my slope is 6, how do I find my tangent line? So we go back to our original algebra where we have y minus y1 equals m times x minus x1. Okay? And then I can fill in my values. Y equals, y minus y1, which is 8, equals 6 times x minus 1. And then that's done really so that you can stop there, but just simplifying the purposes, I have y equals 6x plus 2. And there's my line. Okay, so now we've got average rate of change, slope, and tangent. I am going to give you, the idea here is now we're going to, only adjustment that we're going to do is find the normal line. Okay, the normal line as opposed to the tangent line. So first off, we knew at this point here, we had the tangent line of y equals 6x plus 2. That is my tangent line. I want to focus in on the slope. There's my slope. Okay, remember a normal line is perpendicular. So if I have this going here, my normal line will be perpendicular, forms a 90-degree right angle. This is normal, and this is tangent. Okay, the normal line is always a right triangle going through that same point. So to find the normal, I need to find the inverse slope, the negative inverse. So if it's 6, so my negative inverse is going to be 1/6. This is the slope. And I'll put like that, perpendicular slope. So you know what I mean. Okay, that's my perpendicular slope. And so now all I need to do is go to my formula again. Y minus 8 equals negative 1/6 x minus 1. And then I can finish this out. Y equals, we'll do it this way. X, negative x over 6, plus 8, so 49 over 6. Because 8 times 6 is 48, plus the 1, give it 49. Okay? Slope of the tangent. I'm sorry, slope of the normal. Done. Now, for all you people in the medical field, we want to quickly kind of discuss sensitivity. When I'm discussing sensitivity, what I'm really discussing in sensitivity is how medicine and temperature counteract each other. Like, what happens? So, for instance, if we're discussing fever, how much medicine should you give a person for a fever type deal? And so, like, those type of things, that connection, and that connection that you have is sensitivity is equal to the limit as, what do we want to say? As the change in dosage goes to 0 of the change in temperature divided by the change in dosage. Okay, so that's going to be my sensitivity. All right, we'll look at an example in a second. Another way of saying that would be delta T is equal to the sensitivity times the delta B, or the change in dosage. Change in temperature equals the sensitivity times the change in dosage if my dosage is really, really, really small. So now I'm assuming that my dosage isn't 0 yet, it's going to 0. My change in dosage is going to 0. So it's really small. So I can use this equation here to help with my sensitivity. For this problem, I would have you basically go ahead and read example 9. Instead of me going over it and taking up a lot more time on this, I kind of want you to kind of just look it over because we're going to use sensitivity in a bunch of different ways. But I want to encourage you to think about sensitivity as like, okay, if you're on a balance beam and you put light pressure on this side on a balance beam, then it'll knock the whole thing off. Whereas if it's a heavier thing, it's not as sensitive to your touch, so you can kind of jump on it and it won't move. So I can put my whole weight on something and it won't move because it's not sensitive to my weight at that point. Now, if I move further out or I change the temperature changes, or like you get started close to a melting point, then that sensitivity would also adjust. So the temperature change doesn't necessarily have to be with medicine. It could be with anything. All right. Good luck. Get your work done.